Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name esters using the rules of IUPAC nomenclature. And so the rules for naming esters was really born or inspired from the fact that esters can be created from a carboxylic acid and an alcohol. And so when naming esters, what we're going to do is we're going to break apart the ester such that the first part of the naming of the ester describes the alkyl chain that's coming from the alcohol group. And so the second part, or the second word that describes the name of the ester, is going to come from the carboxylic end. And so to ensure that we're communicating to the reader that this compound that we're naming is an ester, we are going to use the suffix -ate. Okay? And so let's go ahead and take a look at this example that you guys see on the screen. So I recognize that this is an ester because I have a carbonyl carbon and a carbonyl oxygen, and that carbonyl carbon is covalently bonded to this oxygen, which is covalently bonded to this alkyl chain. And so I have to imagine that the formation of this ester came from a carboxylic acid and came from an alcohol. And so anything to the right of this blue imaginary line, I would have to name first. So this is the first part that I'm going to name, because this first part came from the alcohol. And so the second part to the name of the ester is going to describe the carboxylic acid. And then we're going to change the name, or we're going to change the suffix to -ate at the very end. Okay. And so since this is a 2-carbon compound, I'm just going to go ahead and make sure that there's a permanent line, okay, instead of my laser pointer. And so once I've recognized my ester, I'm going to put a line delineating the carbonyl group to that of the ester oxygen. And so since this is a 2-carbon chain, I know that this is going to be an ethyl. And so that's the first word that I'm going to place when I'm naming my ester. And so here, if I look to the left of this pink line, that's going to represent a 2-carbon carboxylic acid. And so typically that would be ethanoic acid. And so it turns out that the parent chain that we're going to be using is the carboxylic acid end. And so since we're using the carboxylic acid end as our quote-unquote parent chain for the ester, we are going to modify the suffix. And so instead of saying ethanoic acid, this whole word that I just crossed out is going to be substituted with -ate. And so if I bring this prefix down, I simply get ethanoate. Oops. Oh no, it's frozen again. And so the correct way of naming this specific ester is ethyl ethanoate. Okay. And so let's go ahead and look at the pieces here. There is a space that's present. And so right now I kind of capitalize this. If you guys lowercase the beginning of the first letter for each of those words, you guys can. My mind just subconsciously capitalized it. Darn, it's stuck again. Okay. And that's pretty much it. So it's pretty simple. So this is, I guess the analogy for naming esters would be ethers. So if you guys recall ethers, you just name one end, then you name the other end, and then put a space between them and say whatever ether, and that would be it. So let's go ahead and go through how to name these esters. So notice that I've already marked in red the portion that's going to come from the alcohol. So we're going to go ahead and name this first. And so since this is a 2-carbon compound, this is going to be ethyl. So that's going to be our substituent. And so since ethyl is our substituent to this ester, it's going to be written first. So next, we're going to go ahead and focus on the carboxylic acid portion, which is this whole thing. And I see that I have 1, 2, 3 carbon compound. And so I'm going to put a space between ethyl, and I'm going to say prop. And since everything is a single bond, I'm going to go ahead and say propane. I don't see any double bonds to the left of this carbonyl group. And so I'm going to go ahead and cross this out and add O8 at the very end. And that would be, this O8 ending is going to represent that of the ester. So notice how I'm not using, the carbon number to describe their positions. So these are pretty simple esters that we're working with. Okay. Now let's go ahead and look at the compound on the right. And so here is my ester oxygen. Anything to the right of the ester oxygen is going to be my substituent for my ester. Since I have a 3-carbon substituent, this is going to be a propyl. And so the propyl is going to come first. Now looking to the left of my carbonyl group, I notice that I only have a 1-carbon compound. And so I'm going to go ahead and put a space between them, and a 1-carbon compound, that prefix is going to be meth. And so since this is an ester, actually let me back up here. So since this is a 1-carbon compound and there is no double bonds between the carbon to, well, actually there's not even another carbon. And so I'm just going to go ahead and say methane. So I'm going to go ahead and drop that E and add O8. Oops. And so this is going to be my final answer, propyl methanoate. All right, now if you guys had said methanoic acid like what I did in the previous slide, and then you guys canceled out the oic acid, and then replace that with the O8, that's also equivalent. And so if you want to say, if you want to express the parent name as an alkyl chain, that's fine. Just make sure to drop the E. If you want to express the parent chain as an acid, so methanoic acid, just drop the oic acid, and then replace that with O8. And that's going to give you the same answer. All right, so let's go ahead and move on to the next organic compound. So I recognize that this is my ester. And so if I were to cut this in half, anything to the right of this ester oxygen is going to be my substituent. And since I have a 1 carbon substituent, I'm going to use the prefix meth. And since this is my substituent, I'm going to use the YL ending to indicate that to my reader or my audience. And so methyl is going to come first because it's going to be my substituent for this ester. Now anything to the left of that carbonyl carbon, including the carbon itself, is going to represent my parent chain for this ester. So here I have 1, 2, 3, 4 carbons. So I'm going to put a space. 4 carbon compound is going to get bute as my prefix. So I have bute. Notice that there's no double bond in this parent chain. They're all single bonds. And so I'm going to say butane. And so I'm going to go ahead and erase the E and put in O8 to represent or to indicate that this is going to be an ester. So I have methyl butanoate. All right. So last example on this slide, we have a 3 carbon compound. Once again, you can split this in half. Anything to the right of that ester oxygen, which is this oxygen right here, that is going to be my substituent. So I have a 3 carbon substituent, which is going to translate into a propyl. Since my propyl is a substituent, that comes first. I'm going to put a space. And then anything to the left of this is going to represent my parent chain. And so since this is a 2 carbon compound, I know that the 2 carbon compound is going to give me eth as my prefix. And so I'm going to put eth. Notice that the bond between them is a single bond, so this is ethane. And so since this is a ester, I want to erase my E and then add O8. And so this is going to be propyl ethanoate. And so the space is really exacerbated, but I just wanted to make sure you guys know that there is a space between the substituent and the parent chain. Okay. All right, so let's go ahead and do 4 more, and then we're going to learn how to draw these esters from their name. And so in the previous examples, I've kind of highlighted all of the substituents with this red color. But, and I showed it to you through the condensed structure form. And so we're going to go ahead and learn how to name these esters using the skeletal structure. And nothing's highlighted for you, so there's no crutch, so to speak. So how do we do this? Well, the first thing I want to do is I want to recognize my functional group. Here I see a carbonyl carbon. Here I see a carbonyl group. and that carbonyl group is covalently bonded to an oxygen, which is covalently bonded to another carbon. And so I know that this is an ester. And so thinking back at how to name esters, I'm going to cut a line between the ester oxygen and the carbonyl group. Anything to the right of this specific oxygen, the ester oxygen, is going to be my substituent. And so let me just erase this real quick. I'll keep it a pink. So here I have 1, 2, 3 carbons. So I have a 3 carbon substituent, which is going to translate to a propyl. So since my substituent is named first, I'm going to go ahead and write that down. Next, I'm going to look at, to the left of my carbonyl group. And so this is my carbonyl group. The carbonyl carbon counts as 1, 2, and 3. And so since I have a 3 carbon parent chain, then this is going to be prop. And then since everything is a single bond, right? So this is a single bond. I know it's going to be propane. Since I have an ester, that means I need to erase this E and then put in O8. So this is propyl propanoate. And I'm done. Okay. So let's go ahead and move on to the next compound or molecule. And so once again, I want to recognize my ester. So here's my carbonyl group. Here's my ester oxygen. And so once I have recognized this pattern, I'm going to go ahead and draw this black line to remind me of which parts to name. So anything to the right of that black line, anything to the right of this ester oxygen, it's going to be my substituent. And so here, notice I have 1, 2 carbon compound. But if you were to, let me just erase this. If you were to draw a line, notice how there's a reflection. It's symmetrical. You can fold it in half, just this part at least. And so since there's symmetry in the substituent, and since there's 1, 2, 3 carbons in the substituent, this is actually going to be isopropyl. Iso, it's symmetrical. Prop, because there's 1, 2, 3 carbons. And so my substituent for this ester is going to be isopropyl. Next, I'm going to go ahead and name my parent chain, which starts from the carbonyl carbon. So this is 1, 2, 3, 4. So since I have 4 carbons, I'm going to put a space. This is going to be bute. Since they're all single bonds in that chain, this is butane. Erase the E, put an O8 to signal that this is an ester. And so my final answer is going to be isopropyl butanoate. All right, so let's go ahead and take a look at this example. This one's a little tricky. The reason why it's tricky is because the compound is flipped. So notice that this is my carbonyl group, but instead of the ester oxygen being on the right, this ester oxygen is now on the left. And so I'm still going to, once I've recognized that I have an ester, I'm going to split that bond in half, remember this bond right here was formed during the esterification reaction between a carboxylic acid and an alcohol. And so I'm using that bond between the carbonyl carbon and the ester oxygen as a reference point. And so since in this scenario the molecule is flipped, that means that anything to the left of the ester oxygen is going to be my substituent. In this case, I have a 1,2 carbon compound, so I know that I'm going to use my prefix eth. So since this is a substituent, it's going to be ethyl. Now, looking to the right of the carbonyl group, including the carbonyl carbon itself, that's 1, 2, 3, 4. So it looks like I have bute, since they're all single bonds. This is butane. Since I have an ester, I need to use the suffix -ate. So this is ethyl butanoate. Okay. So just be very careful. Not everything to the right is going to be your substituent. And so I can always flip it out on you. So you just need to be able to recognize which part of the ester is going to be the substituent, which part of the ester is going to act as the parent chain. And so as long as you guys can recognize the ester oxygen with respect to the carbonyl group, then you guys should be able to discern which part is going to represent the substituent of the ester or the parent chain of the ester. All right. So let's go ahead and take a look at this last example here. So this last example is kind of tricky into it, kind of tricky. We'll stick with that. So once again, I'm going to recognize that this is the carbonyl group. This right here is the oxygen, and notice that it's covalently bonded to another carbon. And so what I have is an ester. And so since I have an ester, I need to identify where, my carbonyl carbon is and my ester oxygen. And that's where my invisible line is going to be. And so since my ester oxygen is to the left of that black line, anything to the left would then be my substituent. So I have 1, 2, 3. And so I have a 3 carbon compound. So this is going to be prop or propyl. So that's going to be the first word that I write down in my final answer. Now looking to the right of this ester, we have a 1, 2, 3, 4 carbon compound. And so I'll go ahead and mark my carbons in pink. And so I know that a 4 carbon compound or 4 carbon chain is going to be bute. Since they're all single bonds, it's going to be butane. Since I have an ester, I need to erase the E and add in -ate. So butanoate is my parent chain. Now, there's an issue with this structure because not all the carbons were highlighted in pink. That means that this carbon right here is going to be a substituent on the parent chain. And so when you have a substituent on the carboxylic acid portion, you're going to treat it as a substituent on the parent chain, meaning that you're going to describe the carbon that it is placed on the longest carbon chain. So this is going to be 2, and this is just a 1 carbon compound, so this is 2-methyl. And so since this 2-methyl is on the actual parent chain of this ester, that means that this 2-methyl is going to go before the butanoate. Now, I need to put a space to segregate my propyl group that came from the alcohol to that of the parent chain that came from the carboxylic acid. And so the first thing that I'm going to write is the substituent on the parent chain. So this is 2-methyl. And then now that I've described the substituent on this parent chain, I'm going to go ahead and add the word, or add the parent right after the 2-methyl. So I have butanoate. Okay, so this is going to be the name of this organic compound, propyl 2-methyl butanoate, where that 2-methyl is on the 4-carbon chain. And so since I have an ester, I need to use the 08 suffix. All right, so hopefully going through these 8 examples or 9 examples gives you an idea of how to name these esters. So let's go ahead and try to go backwards here. So esters are typically known to be the major component for some of these sweet smelling aromatic substances that's coming from fruits. So for example, the major component into the distinct smell of raspberry is butyl methanoate. So we're going to go ahead and learn how to draw, So we're going to go ahead and learn how to draw the structure of this compound from its name. And so since butyl is seen first, I know that this is going to come from the alcohol. So I need to connect this to my ester oxygen. So I have a 4-carbon compound, or 4-carbon substituent. So 1, 2, 3, 4. Now, remember that these have to be carbons itself. So please don't put in oxygen, because if you put in oxygen, notice how there's only 3 dots. So that's 3 carbons, which is propyl, not butyl. And so this is the 4th carbon, and after the 4th carbon, then you're going to draw the oxygen. So this is going to be the ester oxygen. And so now that I've drawn my, now that I've drawn the butyl side of my ester, I need to draw the carboxylic side of the ester. And so I know that this ester oxygen is going to be connected to this carbonyl group. And since I have meth as my prefix, or methane as my prefix, or methan, sorry. Methan as my prefix, I know that this is a 1-carbon compound. And so since I already have 1 carbon, I don't need to put another one. So if you guys do this, then, if you guys do this, then that's a 2-carbon compound. And so remember that my carbons needs to follow the octet rule. And so I have 1, 2, 3. So I need 1 more bond. and that's going to go to a hydrogen. So this is how you would draw butyl methanoate. So the major component of pineapple that gives it its distinct smell is ethyl butanoate. And so ethyl is our 2-carbon compound that's going to be connected to the ester oxygen. So this is 1, 2, connect that. Those are my carbons. And then I'm going to go ahead and draw that ester oxygen, and that checks this off. And so now I'm going to go ahead and work with the butanoate. So butan is telling me that this is a 4-carbon compound. And I know that this is an ester because I have the O8 ending. And so since I have an ester, that means that this oxygen needs to be connected to a carbonyl carbon, which is going to serve as the first carbon for this butan. So butan is a 4-carbon compound. So this is already carbon 1. This is 2. This is 3. This is 4. And I'm done. Okay. All right, so let's go ahead and go through propyl butanoate, which is something that we covered in one of our reactions in the previous lecture video. So propyl butanoate, I have a 3-carbon compound. So that's 1, 2, 3. And so I know that this is going to be connected to my ester oxygen. So I need to put one more covalent bond, and then I'm going to go ahead and draw that oxygen. And so the O8 ending is going to tell me that this is an ester. And so here I have butan, so that's a 4-carbon compound. Since it's an ester, I know I need another carbon that's double bonded to an oxygen. So I'm drawing my carboxylic acid, I'm drawing my carbonyl group upside down, and that's totally okay. And so this carbonyl carbon is going to serve as carbon number 1 for my butanoate. And so to complete this, this is carbon 2, this is carbon 3, this is carbon 4. And so if I don't draw these dots, I'll essentially get a skeletal structure that looks like this. Oops. Nope, I guess that's connected. Okay. And this would be my final structure for propyl butanoate. So hopefully you guys are seeing the pattern. So let's go ahead and draw the ester. That's going to be the major component in the smell of peach, which is pentyl propanoate. So pentyl is a 5-carbon compound. 1, 2, 3, 4, 5. After I draw all 5 carbons, I'm going to extend another line. That's going to be a covalent bond to another oxygen. And so this is going to be our ester oxygen. Since this is an ester, I need to have a carbonyl group that's bonded directly to the ester oxygen. And this is going to serve as carbon number 1 for propan. So propan, or prop, is 3 carbons. So that's 1, 2, 3. And so if I were to erase all of the dots here, this would be my skeletal structure. For pentyl, propanoate. All right, last one, methylbutanoate, apple. And so methyl is a 1 carbon compound, or a 1 carbon substituent. It's going to be bonded to an ester oxygen. And so since I have an ester, I know I need a carbonyl carbon. That's going to serve as carbon number 1 for butane. And butane is a 4 carbon chain. So that's carbon 1, 2, 3, 4. So overall, this is going to be my final structure. All right. And so hopefully you guys understand how to draw the esters from their name. And you guys know how to name the esters based on their structure. So that's pretty much it for this lecture video. We're going to go ahead and move on to the next topic in the next lecture video. See ya.